Okay, so we're at another competitive exam, and again, looking at it, if I were looking through it, what you're familiar with, some problems look better than others, but I'm going to say one doesn't look too bad. It's a visual problem. Two, if you know computer programming, it's not a bad problem. Three looks algebraic in form. It looks somewhat manageable. Four, you would need to know about complex numbers and how to get the six roots of that problem. There's six of them, and that probably going to require some pre-calc knowledge for students, including trigonometry, and then a log problem. All right, I'm going to cut to the chase, and I want to point out that you really, when I say cut to the chase, I'm going to work through my solution to the problems. But here's the deal: you should look at this and try to complete that in about, I'm going to say 60 minutes. Does that mean you'll get every question? No, but it means you'll try, and trying is really the first step in getting these answers correct. Let's take a look. I'm going to go back and I'm going to look at the answer key, and I'll walk you through it. And certainly the first problem, really, I just see the answer says 3. So I'll read it to you, and the first thing it says is you got a cube. All right, so the edge of a cube. I'll put this over here. These are what the edges look like. And I'm doing my best job at drawing what looks like a cube to me. So it says, the edge of a cube is painted either, ooh, I made a mistake here in the writing of this. I have to correct that now. This should read red. All right, sorry about that. So every face of the cube has at least one black edge. All right. So you know what I'm going to do? I'm going to paint a red cube now, with all the edges red. All right. Now what do they say? Again, reading it says, every face of the cube has at least one black edge. Well, I'm going to go back to black, and I'm going to paint this one black here. All right. Now, someone says, there's two sides that share that edge, and I hope you realize the two sides that share that is the top and the very back of it. All right. Now, again, what's the smallest number of black edges, right? If every face shares a black edge. Well, let me draw another one. See what I come up with. I'm trying to draw the minimal number. If I did that, it would be this one. That's the left side. I know it's hard to visualize that, and the front side. All right. Now there's a couple of sides I haven't covered yet, so it's going to be this one over here, which will cover this one and the bottom one. So I'm going to say 3. Certainly makes sense to me. All right. So let's take a look at the next one. As I'm doing these things over here, I do want to point out, reading it's a stepwise problem. I have to read this, 1 step, 2 step, 3 step, 4 step, 5 step, 6 step. So reading it says, x starts at 3. So I'll put this over here. So x, I'm going to call x1 starts at 3. And I'm going to say s1 starts at 0. All right. Now it says over here, step 2, increase the value of x by 2. So if I did that, I hope you realize it's arithmetic now. So x2 would be 3 plus 2. And if I keep doing this over here, which we'll keep doing it, and it does say keeps doing it, so I increase it by 2. And I'll go to step 3 later, by the way. But this step keeps being repeated until some n comes. We don't know what the n is. We haven't read that far. So I'm going to say xn is going to be a1, which is 3, plus, this is arithmetic, n minus 1 times 2. So xn is going to be what? It's going to be 3 minus 2, which is 1 plus 2n. All right? Let's just check that. If it's 1, I'd get 3. If it's 2, I'd get 5. Yeah, it looks like it's pretty good. All right? So I kind of understand how this is moving along. Then it goes on and says, the third step, right? I know how this thing is moving along. And you could write this down if you like, one step at a time. It's going to be a long process, though. What they say is increase the value of s by the value of x. So what I'm going to say over here, Sn, well, what's the first value that's going to be added onto it? It's actually going to be x2. And then I'd go x3. All right, and then I'd go x4. Right, let's keep going. All right, let me write this over here. Sn is going to be x2 plus x3. But again, I don't know when this is going to end. This could be endless, an endless loop, so to speak. x3, x4, plus yada, yada, yada. And again, the end could keep moving on. I just don't know where the end is at this point. And that last term is going to be, let's see, I'm going to write down 1 plus 2n. Now, how many terms are here? I'm saying this is xn right over here, right? And so how many terms are going to be? Well, n minus 2 plus 1, so there's n minus 1 terms. Now this is a sum of an arithmetic series, so or sequence, I should say. It's a series, by the way. So let's write down Sn as a sum. So it's going to be n minus 1. Let's see, what's x2? x2 is 5, right? I'm doing this over here. I'm just writing the first term and the last term. And the last term is 1 plus 2n. Divide by 2. That's the sum of an arithmetic sequence. And I'm going to write this down as Sn equals n minus 1. And I'm going to, I'll point out what I'm looking at this, and I'm going to divide through that. That's 2n plus 6, so it'd be n plus 3 now. I'll write that down for you. And what do you get over there? Sn would be what? N squared plus 3n. Minus n is plus 2n, right? And then minus 3. So I got some important facts over here. And I'll tell you what the facts I have at this point. I have this, and I have this. And again, I got to keep reading the code. All right, so I'm kind of checking off things as I'm reading through those things. And let's take a look over here. I'm doing this. Oh, it says S now is at least 10,000. This is the part where I might bog down, by the way. And I'll write this down for you. So n squared plus 2n minus 3 is at least, all right, this is important. So it says if S is at least 10,000. So my question is, when does that occur? Right, and this is where I would probably bog down. All right, so I'm going to look at that, and I'm going to try to figure it out. But I do know this. I know n. I know it's an integer. Now, certainly you can use quadratic form if you want, but the bottom line, I'm going to look at it, and yeah, kind of looking at it. I'd hate to do this, but I'm going to try n as 100 first. Now, someone says, why are you doing that? It's a number that's going to give me the 10,000, certainly. So what are you going to get? 10,000, right? And then what do you get? You get plus 200. And then you get minus 3. And that's definitely for 100. But I'm not saying that's the number. I'm just saying 100 definitely is the upper limit on it at this point as far as I'm concerned. What I want to do is I want to do 99. I want to see if 99 works. All right? Now, what's the problem with 99? It's going to require some work. All right? Going backwards. I know 100 is good, though. So n is 100 is good. I know that. But I want to try 99. And 99 squared, let's do that. Let's see, 9 times 9 is 81. Let's see, 9 times 9 is 81, right? 81, 89. Gee, that's not so bad. Well, I just did that. So 1, 9, 8. This is going to be 1. This will be 10. That'll be 18. So 9, 8, 0, 1. And let's see, 2 times 99 now, right? I just did the n squared. 2 times 99 is 198. And then I'd have to take 3 away from that. And I hope you realize that 99 is too small. So n is 100 is the number, all right? That's the number. What's their question now? Let's go back and read it. All right, so I know when I hit 100 that this event's going to occur. What do they want me to do? Print the value of x. So let's write this down. So x, 100, and mistakes can happen, by the way. That's what we're pointing at over here. So let's see, what's that going to be? It's going to be 1 plus, I'm looking at this over here, plus 200. So the answer is going to be 201. All right, let's take a look. See how we did? Yeah, we did okay. It's going to print out 201. All right, so that's number, we just did number 1. And number 1's visual. Again, I sometimes get confused with visual problems too, and that varies from person to person. Some people can visualize these things in their mind. Other people have to draw pictures, whatever. 2, I'm going to say you probably need to know some coding, all right? And I'm going to say code, you probably should learn some coding, right, how things are done in steps, all right? Let me put down number 3 for you. And they tell me f of x is equal to ax squared minus the root of 2. And they tell me that a is a positive number. All right? So what I want to do is I want to look at this over here. And I'm just going to write down f of root 2. What would that give me? And I'll be careful about it. It's going to give me 2a minus root 2. All right? So So I got this part covered. Let me point out I got this part covered. Now what I have to do, I have to do f of this number. And let me write that down for you. F of this number. Well, I'm going to look at it, and I want to remind you this is what f is. Whoops, I didn't mean to do that. So this is what f is. So I'm going to write down what it does. What does it do? It does this. It does a times that number squared right, and then minus root 2. And what did they say it's equal to? Well, I have to read it. It's equal to this thing over here. And let me write that down for you. So this is going to be a, whoops, sorry about that. A 2a minus root 2 squared minus root 2 would be equal to minus root 2. Well, I'm starting to think that this is a reasonable problem. And someone says, I don't even know the question yet. They want to know what the value of a is. Remember, a is a positive number. I don't know that yet. So let's put this down. So what do you get? You get a, and then you get 2a minus root 2 equals 0. What I do, I subtracted, I added root 2 to both sides. So I'm going to say a could be 0, all right? And we'll check it, by the way. Or a could be what else? A could be, let's see, what could it be if, I'm sorry, this is square over here. A could be root 2 over 2. By the way, I kind of prefer to write this number as 1 over root 2, but either number's okay. And let's write this down now. Let's see if it works out. I'm going to check the 0 first. I want to, by the way, if I was in a competitive exam, I don't think I'd be checking this. I'd move on to the next one. If I had extra time, I'd check it, though. So what do I say? F of x. Wait a second. That can't be the number. Why is that? They told me that a is a positive number. So I wouldn't check this, right? I'm going to do the other one. So I'm going to check a is 1 over root 2. And I'm going to plug that into the original function. So f of x is going to be x squared over root 2 minus root 2. I'm going to check this out now. F of root 2. Well, that's going to be 2 over root 2 minus root 2. And that equals, let's see, put that down. What would you get over there? Let's see, you get root 2 minus root 2, which is 0. That's good. And then I do this over here. What's f of 0? Again, I'm just checking it with the original statement up here. And this should equal minus root 2. Whoops, sorry about that. Get my eraser out, a little haywire there. I'm going to start to erase things that look crazy to me. So, f of root 2, whoops, f of root 2 is 0. And now I'm going to do f of root 2. Well, that's going to be f of 0 now. And what I say that's going to be, I said that's going to be this function over here. And what would that give you? Clearly gives you minus root 2. So the answer is what we said it is. It's this thing over here. This is what a is. It's right over here. All right? Again, a was a positive number, meaning it's greater than 0. All right, number 4, you're going to need to know how to do the roots of this. And it's something you may have studied in a trig course. You may have studied in trig course. And what's nice about the trig course is that, if you could just visualize the number, that there's a good chance you'll be able to do the problem, all right? Now, someone says, what do you mean visualize that number? And, to visualize that, I'm looking at it, it's the 6th power, and that's minus 64. Let me see the good way to visualize this. I'm going to start to erase this over here. You know what? Maybe I shouldn't. I'm going to erase this part over here. It's just my checking over here. All right. Again, this requires trig. So let's write these down now. And I'm going to, kind of think through this over here. So let's write this one down for you. And, I'm going to write this over here. So x to the 6 equals, let's see, minus 64 plus 0i. That's my a plus bi form over there. All right, and then you would need to know Dwarf's theorem and working backwards from that, how to get the roots from this problem over here. But I want to write the trig form of that problem down, all right? And someone says, what do you mean the trig form? I'm going to visualize the number for you, all right? Hopefully this brings back your memory of pre-calculus and specifically trig. This is the real part. This is the imaginary part over here, all right? So where would that number be? Well, it's over here. It's minus 64. And what's the argument over here? It's actually 180 degrees. All right? And what's the r in the problem? The r in the problem is going to be what? That would be 64. So if you were to write this complex number here, x to the sixth, that complex number would be 64. And then what do you get over here? You get this, the form of it, I'll write that down for you. It's going to be cosine of 180 degrees plus I sine 180 degrees. Now, by the way, that's the same thing as saying what we got up over here. It's the same exact thing. But then someone says, how do you do the root of that? And that's where things get a little sticky for some students, all right? So, certainly if you don't remember this or you didn't do this, this would be tough to do. And I'm going to write the roots down. So x, and the way we normally write this down is I say first, and then I say second, and then I say third, fourth, and I get up to the fifth one would be all the 6 roots. So really what you're doing is you're taking the 6th root of 64. I'll write this one down for you. And this is a principal root, and that's just the number 2. All right, 2. So all of these things are going to have a 2 in it. Let me write these down for you. That's a 2. And there's going to be 6 roots, by the way. Now, here comes the problem. And what I'm going to say over here is that I really don't enjoy writing this down. And we have an abbreviation for it. And the abbreviation is CIS. All right, now what does that stand for? Cosine of an angle, theta, plus I times sine of the same angle. Question is, how do you get the angles? And this is the part where a lot of students get tripped up on. It's going to be 180 degrees plus 360 degrees. Let's see, I think I use an N or a K. I can't remember. I guess I'll use N. Over a divisor. And the divisor I'm going to use is the number 6. And then you start taking your numbers. I want to point out what the numbers I'm using. These are the N's. And I'm going to write this down for you now. So it's going to be CIS of some angle. I'm using degrees for a reason, by the way, because it's easier for me, but they really should be in radian measure. But I like degrees because they're really easy for me to write it down. The arithmetic is very simple. So if I chose n to be 0, what would I get? 180 divided by 6, which is 30 degrees. These things have a nice pattern to it, by the way. You may not see that until you start doing it. So I'm going to write down, 6 into 180 is 30 degree times, and then 6 goes into 360, 60 degree times, and that's n. So I just simplified this. To make it easy to do the arithmetic, when n is 1, what do you get? 90. Now you should start to realize these things are going up by 60. What's the next one going to be? 150. What's the next one going to be? 210. What's the next one going to be? 270. What's the next one going to be? 330. Now, by the way, someone says, what if you kept going and you kept adding 60 on? You just keep repeating these guys over and over again. It's cyclic. All right, you just keep repeating it. Now, someone says, I don't even know what the question is, and it's true. If you don't know the question, how could you possibly answer it? Basically, if you have 6 solutions of it, I wrote them down, and you should write them in the form a plus bi, where a and b are real numbers. And then it says the product of the solutions where a is greater than 0. Well, you know what? I don't have that part yet. So what's this a going to be? It's going to be a plus bi. So I need to write that down for you. All right? And that's, I need to know things. And, some of the things that are really easy for me to do, I'll write this on the side for you, though. I'll write x0 down, x1, x2, x3, x4, and x5. Now, of course, I'm going to do the easy one first. What are the easy ones? This is easy, and this is easy. That's 2 of the easiest ones I've got going for me. And why is that? 90 degrees is really simple. And like if I did 90 degrees, I hope you realize the cosine of 90, let me write this down for you. This is x1, would be 2. Then I'd get 0, right? I'm doing 90 degrees, right? That's cosine. And the sine of 90 is 1, so it would be 2 plus I. What does that give you? 2i. Notice that's written right over here, all right? Let me do the other one, the x4. That's 270. That's going to be 2. I'm just going to do x4 now. I think it's easy to do. And again, some people are faster than others. Cosine of 270, again, kind of visualizing that, and that would be 0. And the sine of 270 is -1, so minus I. What number do I get over there? You'd get basically 0 minus 2I, and I got this written over here. All right? Now let me do the other ones. And the other ones I'm doing, they all have something to do with 30 degrees. So I'm going to say the reference is 30 degrees for all these problems over here. All right? So I'm gonna put a 30-degree triangle down for you. This is 30 degrees. This would be 1. This would be 2. This would be √3. All right? So I'm going to say, x0 is pretty easy to do. And what would you come up with? It would be 2, and 30 degrees would be what for cosine? It would be 1 over 2, right? And I'm sorry, √3 over 2. I'm daydreaming again. And what's the sine going to be? It would be a half. So that'd be I over 2. And I'm going to say if I multiply that, you get √3 plus I. And I got this right over here. By the way, you also may remember when you took your trig class that they said that these things would occur in conjugate pair. All right? By the way, when I say trig class, I also say pre-calculus. Complex roots are going to occur in conjugate pair for a real coefficient polynomial, which this is. So I'm going to see this guy over here somewhere too, but let's just do one at a time. So what I just did, I guess I did this one here. Now what I'm going to do is I'll do the 150 now. And it's pretty easy because 150 has a reference of 30 degrees. So it's going to be 2. And let's see. I'm going to do the cosine of 150. So that's going to be minus √3 over 2. And then the sine of 150 would be a half, so I over 2. And what do you get over there? You get minus √3 plus I, and that's right over here. All right, I'm seeing that. Okay, we'll get to that question later. And, I'm looking at that, and I want to keep going around here and around. I just did this one. I guess I should do this one next. And that looks pretty easy to do. What do you get? 2. And we're doing 210, right? So that's going to be minus √3 over 2. And minus I over 2 now. And what does that give you? Minus √3 minus I. All right? That's right over here. I think you're getting the idea of the pattern for this problem over here. And the pattern's fairly simple to come up with. Let's do the last one, which is the cosine of 330 degrees. Let me write the number down for you. The cosine of 330 is going to be √3 over 2, and then minus I over 2. All right, what do you get over there? You get √3 minus I. And I got that as well. Now, someone says, I didn't know what the question is, and did I need to write all of those down? Not really, but this is just like a review of what you've done in your trig and pre-calc classes. What do they want to do? They want to, the 6 solutions of it. I got them all down, by the way. They want to know, let's see, the product of the solution where A is greater than 0. All right, let me read this down again. There's 6 solutions written in the form A plus B. I have them written down for you. Where A and B are real numbers, I've got that written down for you. The product of these solutions where A is greater than 0. Let me remind you what we're looking at. We're looking at A plus BI. Where's the A greater than 0? I'll circle them for you. This one and this one. They're the only two answers where A is greater than 0. What do they want me to do, though? They want me to find the product of those two numbers, and I'll write that down now for you. The product of √3 plus I times √3 minus I. That's what they're asking for. Well, √3 times √3 is, your conjugates, by the way, is 3, and then you get minus I squared. What would that give you? 3 minus a minus 1, which is 4. And that's staring at you right over here. All right? Now, again, if you saw it as a tough problem, you skip it. If you didn't know about, the trigonometric forms of complex numbers, you'd have a tough time over here. You would. You'd have a tough time. Now, granted, I realize what some people are saying is that, what if I did it differently than you do, and I didn't see what you were saying about this problem over here. You have to understand when you're doing a competitive exam, someone's looking at the work of other people too, and they're trying to select what the best looking work is. And certainly if there's more than one judge, they'd have to, compare, the top scores to find out who really does the best job of answering the questions, all right? And, someone's going to, always lead the pack, by the way. At least I hope so, all right? What I mean by that, if everyone's performing at the same level, it's not a very good exam, all right? So let's take a look, and I'll look at number 5 for you. And number 5, I'll be honest with you, it looks a little tough for me. I'm going to start to erase the stuff over here. And if I were looking at that, I know it says that x and y are positive numbers, right? So I'm glad for that because it makes it a lot easier for me over here. And they say the log base y of x plus the log base x of y equals 10/3. And they say that x times y is 144. But then they go on to say, what's this thing? I don't know. So I'm going to say it's a big question to me. So what I'd like to do is, these look really complicated to me. And so what I would probably do is I'd simply probably just say u is equal to make it simpler for me. All right? So this is a typical thing we do in mathematics. If I see something complicated, I say, I'll just make it u. And what do you got over here? Log base y of x. And what I'm going to do is rewrite this as an exponential problem. And what do you get? You get y raised to the power u is equal to x. All right? Now, by the way, what I'm going to do now, is it might seem really strange to you, I'm going to go back to a log problem. All right? And it may not work. I'm just playing around with it because I see I just did this part. Now I want to see if I can get log base x out of this thing. So I'm going to take the log base x of y to the u is equal log base x x. Well, this looks rather easy to me, and I'll tell you why. This guy over here is just 1, because x raised to the 1 would be x. I'll write that down for you. And this guy over here is just simply u times log base x of y. Now, you might be totally confused right now, and I understand that, but I have this down, and I have this down, all right? And they both involve using the logs I want. So then the question comes is, what do I really want to come up with? I want to get an equation that I can solve, all right? So let me just point this out again. I'm looking at this, and I'm looking at this, very complicated, and looking at this. Do I know what log base y of x is? It's right here. What is it, u? Do I know log base x of y? I see it right here. What's that going to be? 1 over u. What do you get now? 10/3. All right, what am I going to do now? I would say probably clear the fraction, and let's hope it's easy to do. I multiply both sides by u. You would get u squared plus 1. Oh, you know what? I want to do something more than just u. I want to do 3u. So the LCD is 3u. Sorry about that. And let's hope it goes easy. 3u squared plus 3 equals 10u. 3u squared minus 10u plus 3 equals 0. Wow, this looks going to be tough, right? So what do you get over here? 3u, u, 0, and I'm going to say 3 and 1, minus minus. Let me see if that works. You get 3u squared minus 9u minus, yeah, it looked beautiful. So there's answers over here. U is 1/3, and u is 3. I don't know which one's going to work, or if both work. All right, so then the question comes is, how are you going to do that? Well, I got to work backwards, right? I really have to work backwards. And, working backwards on a problem, that can be problematic. I notice there's some errors over here. I want to point out the way I typeset the log is incorrect. I have to correct that. Log should not look that way. All right, let me see if we got the right u's in the problem. Yep, 3 and 1/3. All right, so let's take a look. And I'm going to write this down now for you. I'm going to write down what I know u is. Let's write this over here. I know u could be, let's try the 3 first. So what would you get? You would get, let's write this down. Let's see what we're going to write down. First, let me see what the question is. The question is, if x and y are positive, and then they got this xy is 144. Let's write this down then, all right? This is going to be tough. So I'm going to put down y, I'm trying it 3 now. Y to the cubed is equal to x, all right? So I'm going to use this here, and I want to see if this makes any sense to me. And if it doesn't, it doesn't. That happens sometimes. So it's going to be, let's see, x is y cubed, right? times y is y, right? That's 144. Well, let's see what happens over here. And what would you get? You would get y to the 4th power equals 144. And let's see what that would give me. Make sure I didn't make any mistakes over here. So I did this here, right? So y, I'm saying u, that's y cubed is x. And I did that. Well, this is going to be 12. It's going to be the root of 12. Let me just make sure of that. And that can be tough. I know that. So that y is the root of 12. And that's going to be y equals 2 root 3s. What does x equal, though? X would equal the cube of that number. So it's going to be, I have to cube it now, right? So it's 2 root 3 cubed, which is 2 root 3 squared times 2 root 3. And what's it going to give me? 4 times 3 is 12, and 12 times 2 is 24 root 3. All right? Now, what do they want to know? They want to know x plus y over 2. Let's write this down. X plus y over 2. And let's write that down. And x is 24 root 3. And y turned out to be 2 root 3 over 2. And this would give you 26 root 3 over 2, which would be 13 root 3s. Now, certainly sometimes the mistakes happen all the time. And I want to point out we did put this one over here. The only thing I really didn't do, by the way, I didn't do the third one. Let me just write that down for you. So I'll do this one over here. And what's that going to be? Again, I've got to write this down for you. And I want to point out, there's something about this problem. It's quite symmetric. So I'll put this over here. Y to the 1/3 is equal to x. What I would do is I would cube both sides. And what would you get? You would get y equals x cubed. And we're really back to this problem over here. We're back to that one. So we're going to get the same answer twice. So no matter what I would know how to choose, whether I choose this one or this one, I'm going to be led back to the same result. All right? What's that result going to be? 13 times root 3. That's right over here. All right, so I think we did everything. And some problems are more difficult than others. So let's just go back and rehash it. Again, if I were looking at these things, low-hanging fruit for me, in hindsight, by the way, this one was pretty easy to do. This one was easy to do. If you know coding, this one, if you didn't know coding, this would be a horrible problem to do. This one, you need to know some trig, de Moivre's theorem in particular, and this one you need to know about logs. But again, I think there's really basically 2 low-hanging pieces of fruit over here. Number 1, pretty easy. Including if you get it wrong, it's easy. Easy to get that wrong quickly. And this one wasn't bad. It's the other ones that cause trouble. All right. If you need to reach out to me, though, my name is Bannon. My email address is also Bannon. B as in boy, the @ symbol, NNON. And that should look like Bannon, by the way, .us. All right. So if you need to reach out, please do. However, if you do reach out to me, please tell me where you are. Tell me you're in Part F, 2.6.1, and you're trying to do question number 2, and you think I made a mistake, and you're really good at computer programming, you let me know, all right? I don't think I made a mistake, but if you think I made a mistake, maybe I did. Maybe I need to correct my notes, all right? Hopefully this has been helpful. Again, thank you so much for paying attention.